Everyone. Whoops, sorry. Morning. Thank you for joining us. Gotta flip through the page. All right. For those of you that know me, my name is Laura Kroger. I'm the Research Operations Program Manager for the Office of Research and Innovation. Welcome to the 2023 University Research Symposium. We are very excited you're here. To start, I want to go over a couple logistics before we push over to breakfast and mingle. Our bathrooms, if you have not been in James B. Hunt Library, are straight across this opening door, and they're in a yellow alcove. So that's where you'll find bathrooms for today's event. We do have light breakfast fare, coffee, tea. They're all going to be available for you in this open space throughout the day. And then just don't hesitate to grab a snack or drink when you're mingling this morning. And then the last thing I want to mention is many of the resources that we'll be going over today or mentioned by our speakers in today and tomorrow's program, they'll be posted on the University Research Symposium webpage, hopefully by early next week. That webpage can easily be found by typing in go.ncsu.edu/research-symposium. All right. So, for our start of the program, we're going to have a breakfast and mingle session with a couple of NC State centers and data science or AI research groups. These resource groups, have provided a one-pager for our audience that provides a brief snapshot of their group, but we also encourage you to stop by each table, get to know who is behind that resource, and how these groups can help you in your research with data science and AI. So I encourage everyone to get up out of your seats, going over to the far side of the room. Again, light fare, coffee, tea, and drinks in the middle. And we have a couple of the resource groups on the outside. So mingle with your peers, mingle with the resource groups. And we're going to do that probably until 10 or 10:15. And then I'll ask you to sit back in your seats for the remainder of the program. Everyone get up at once. All right, good morning again. At this time, I'm going to start asking our groups on the side to come on and take your seats. Go ahead and grab your last coffee or snack and join us over here at the round tables. I'll give you 30 seconds. All right, as you're taking your seats, hope you were able to meet some of the representatives from these amazing resource groups we brought to you here today. Don't worry, many of the representatives, they're going to be here throughout the day, so if you'd like to continue to connect at lunch and other networking sessions, many will still be here with us. At this time, I'd like to ask our Vice Chancellor for Research, Dr. Mladen Vok, to come up to the stage. Mladen's going to provide us with a brief welcome for today's program, and we'll get going.
Thank you, Laura. Good morning, everybody. I hope you are having a good day. I'm working on the sun, but will hopefully get better. Good morning, ladies and gentlemen. I'm Mladen Vok, Vice Chancellor for Research and Innovation, if you don't know me. And it is a pleasure and a privilege to see you here. Thank you for joining us for this 2023 University Research Symposium. And before I continue, I just want to take the opportunity to thank the organizers of this meeting, and particularly Laura and her staff for doing everything to make it happen, but also RLA and DSA. And it's a lot of work, and I'm very grateful for what they do. So every year, the Research Leadership Academy works to bring an emerging and cross-disciplinary topic to the NC State community. For 2023, the RLA has collaborated with the Data Science Academy to bring you a symposium focused on the topic of data science and artificial intelligence. The domain of artificial intelligence is progressing at a breathtaking pace, or at least it seems that way. Today, there is probably no discipline that does not employ AI analytics in some form. Still, true artificial intelligence remains the stuff of science fiction, stories, and possibly future. I'm biased in that respect. I still think of AI as a collection of if-then-else statements, sometimes a very sophisticated and possibly dynamic collection based on a lot of training and tuning. Often, AI systems are not interpretable. They are black boxes that, like people, make mistakes and have biases. An open concern in this context is, can we detect and understand any bias an AI algorithm may have before its use results in harm to humans? And the answer is no. Right now, we are at a loss in that space. However, as a tool, AI holds extensive potential for good. But perhaps more than many other tools, it also holds an equally scary and maybe even bigger potential for bias, bad advice, and personal and community danger. Verification and validation of trained black box AI solutions is challenging, and researchers and developers of AI need to design their systems to allow detection and understanding with a high degree of confidence of possible associated systematic errors and biases. For example, we all hear about ChatGPT. Version 3, for example, can be very helpful, but it can also come across as lacking common sense Not that it thinks, but certainly comes across like that. And when pushed on its failures, it is quick to throw its training under the bus, and it sometimes hallucinates, lies, and is defensive. So those are not very good traits. Its younger brother, GPT-4, can pass exams and even hire people on its own. That part is scary, because if one day we work for an AI, I would prefer it to be leaning to the good side, and I assume you would too. We all would, I would imagine. Nevertheless, advanced AI may and does provide considerable positive difference when it comes to student learning. A good example, for instance, is the National Science Foundation AI Institute for Engaged Learning. PI is Dr. Lester. Discovery of new medical treatments, security, and so on. It's very important to look at AI in the context of domains. And today I'm hoping there's going to be a lot of discussion of how domain-specific AI operates, how it's constructed, and what the benefits are. And NC State AI profile is considerable. And throughout the next 2 days, we will explore the emerging role of AI in research through open conversation, panel discussions, faculty presentations, visual facilitation, and networking opportunities. Faculty from across the university will highlight the many ways NC State research, teaching, and outreach work addresses the impacts of data science and artificial intelligence. At the higher level, the annual University Research Symposium aims to introduce researchers and scholars to one another, providing a space for them to explore opportunities for new partnerships and envision the future of research at NC State. So again, thank you for being here. Thank you for what you do for NC State. And NC State, by the way, thanks to your efforts, is doing quite well in the research domain. And enjoy the symposium. Thank you.
Thank you, Mladen. And I think Mladen did a great job of recapping what we expect to see in our program over the next couple of days. But I did want to give you a quick brief snapshot of what we'll have. So we're going to start today with conversations, and we'll have a special guest joining us around 11 o'clock. Later today, we're going to be seeing a documentary called Coded Bias. On day 2, we'll also be hearing from some highlighted speakers from our NC State community. Day 2, we're going to start with a panel on the AI Bill of Rights, and then we're going to lead into some additional faculty discussions and presentations, a facilitated discussion at the end of the day, as well as many and various networking opportunities over lunch and a social on day 2. So with that, I want to get our program started. I'd like to ask our 3 conversationalists to join me on the stage. So as they're doing that, I want to turn the stage over to Drs. Ray Levy, Kranos Williams, and Allison Wilson. They're going to get our conversation started about foundational ideas in artificial intelligence.
Good morning. How are you all? Did you enjoy? Raise your hand if you met somebody you hadn't met before in the first session. Me too. I met about 7 or 8 people, and I was really happy to have that time. So thanks to our organizers for making some time and space for us to get here late if we needed to, and also to really meet each other and get to know some of our institutes from across campus. So we're going to introduce ourselves. I'm Ray Levy. I'm the Executive Director of the Data Science Academy here at NC State and a Professor of Mathematics.
Hi, good morning. My name is Kranos Williams. I'm a professor in the Electrical and Computer Engineering Department, and I also serve as the Platform Director for the Data-Driven Plant Sciences Platform for the North Carolina Plant Sciences Initiative.
And good morning. I'm Allison Wilson. I'm a Professor of Statistics and Associate Vice Chancellor for National Security and Special Research Initiatives in the Office of Research and Innovation.
So as I was walking around this morning, many of you are experts in your fields, and your fields are very closely related to data science and artificial intelligence. But I also met many people in this audience who said, I know some things, but I'm here really to learn. I'm really new. I'm really interested in what this new space might be like. I've heard about it. And so we really wanted to start with a conversation to lay some groundwork around what is artificial intelligence, what is some of the terminology that we hear flying around. So some of you will be familiar with everything that we say, and you can come argue with us about it afterwards. We'll have a great lunch. But for others of you who are really new, we wanted to make sure that as you're listening to the lightning talks and you're hearing some of this terminology, that you feel like you have some background in what is it that people are talking about, and can go find out more about some of these words.
And Ray, let me say, the other thing that I wanted to say is, at NC State, we work on really broad areas of artificial intelligence. There are people who are working on foundations and computation. There are people who are applying AI to solve lots of problems all across the university. There are people who are really interested in the societal implications of what's happening around AI. So that's another part of what we're hoping to do today, is to help you figure out sort of where across this continuum of all the work that we're doing does some of your work fit. And if you're working on applications and you say, well, if I could just figure out how to make this run a little faster, you might actually have a chance to meet that person who works in foundations who always says, if I just had an application to try my algorithm out on. And so that's another part of what we're hoping that we'll be able to do over these 2 days.
And you were talking a little bit the other day about common ground, how we might find some common ground here. Can you say a little bit more about that?
Absolutely. I think that what you have up here in terms of the experiences, in terms of the research, is pretty common in terms of what you would find out in the audience and in general. And the fact is that when you start talking about artificial intelligence, when you start talking about some of these other aspects, you don't have the level of common ground in some cases, that common terminology, the common understanding of what it means to be able to apply some of these algorithms. So I think that what we really would like to see is to get to a point where we have some sort of common language, a common level of understanding of what these things are.
So we're going to start with artificial intelligence. What does that mean? So Allison, can you start us out with artificial?
Sure. So when we're talking about artificial, what we really mean is we are really talking about computers and machines. And so AI is not a new idea. AI really started getting some traction back in the 50s. But when we're thinking about AI and you're starting to think about why it's taking off, a lot of that growth is coming because of the improvements in machines, in computation, in storage, and a lot of those kinds of opportunities. So when you think AI, the first thing to think is computer.
And then intelligence.
I think for me, intelligence really boils down to decision making. How can you use information, use data, use observations to be able to make more informed decisions on a particular topic?
And has AI kind of changed over time, what we imagine it can do? I think Dr. Volk, mentioned a little bit the promise or the reality of AI.
Sure, I'll jump in. When you think about some of the AI from 70 years ago, I think there was initially an idea that the computer was going to really mimic what a human did. And I think that right now, if you're taking a look at what's happening in AI, that's much less emphasized than it used to be. I think what we're starting to see is a lot more emphasis on thinking about the humans and the machines as collaborators, as partners, as thinking about how do we let the machines do what the machines are good at, and how do we let the people do what the people are good at, and then how do you figure out how to let them engage and work as teammates.
All right, so that about covers AI. We're going to move on to the term data science. So I've been in many, many meetings this year where people have said to me, what is data science? And I think it's really important that we as a community of researchers find ways to talk about these terms and remember that if we can't talk to anybody about them, then our research will have less impact. So again, if we can now define artificial intelligence in a way, most people can understand it, even if they're not all that interested. What about data science? So a lot of people have asked me, how are data science and AI related to each other? Are they the same thing? Is AI replacing data science? And so we had a little debate about it, and we came to an agreement amongst ourselves, I think. They may have changed their minds since last time I talked, so we're going to see. That data science is a big umbrella. And AI is one set of techniques and tools within that umbrella of data science. What do you think?
I tend to agree. I think that, at least for me, data science covers the entire gamut. So I said earlier, in terms of my interpretation, intelligence side of artificial intelligence comes down to decision making. But data science comes down to any type of interpretation of information. So whether that's visualization, whether that's computation, etc. So for me, data science covers all aspects of working with information, where artificial intelligence really focuses on trying to capture the essence of what are the underlying principles behind the decision, trying to mimic that in some way, and trying to basically automate that process effectively.
And okay, so we mostly agree. But as I introduced myself, I'm a statistician, you know, and when I'm thinking about data science, when I'm thinking about AI, you know, I'm also not just thinking about the decision, but maybe the original question that was asked. And so I tend to think about two different kinds of questions that I might ask about data. And the first one I tend to think about, I call descriptive questions. So when I'm looking at the data, what's going on in the data? Are there groups in the data? You know, what is it that I can understand about the data itself? Descriptive kinds of things. The second kind goes by many different names. It's often called, technically for a statistician, we will call it an inferential question, but, or a predictive question, or really just something where I'm coming in with a question and I want to use the data to help me answer that question. And so when I'm thinking about artificial intelligence, often I'm really thinking about in terms of what is the AI technique or method helping me do? Is it helping me describe what's happening in the data? Maybe it's helping me find clusters within the data. Or is it helping me do something inferential or predictive, helping me answer a question or look forward within the data? And so it's related to decision making, but for me it also gets back to fundamentally what am I trying to do with the data? And then because data really underlies everything, then I'm sort of linking back to the issues around data science.
Great, thanks to you both. So we hear AI and then we hear machine learning. Is it important to make a distinction between AI and machine learning? So I've been asking several people this over the last week. Is it important? And so what I've been hearing is there are individuals, perhaps in this room, who will say it's super important to make a distinction between AI and machine learning. But there will be others in the room who will say, that's a pretty fine distinction and there's a significant amount of overlap. And maybe that's because AI, artificial intelligence, ML, machine learning. Remember that artificial has to do with the machine. And so the artificial and artificial intelligence is associated with the machine and machine learning. And then the intelligence part, maybe that is like the learning part. And so again, artificial intelligence, machine learning. Machine learning, to me, even though maybe AI has been happening for a long time, to me ML is a little bit of an older term. And the hotter, newer term seems to be AI. And I see people describing a lot of machine learning algorithms as AI because I think that's what you're seeing in calls for research proposals. You're not seeing as many calls for machine learning research proposals, right? You're seeing this broader umbrella of AI in the research proposals, and that's going to drive what language we use when we're proposing our research because we're going to be answering those calls. Anything you want to add to that?
That's a tough one. For me, there's a lot of context there, and a lot of terminology that is reused, used in different contexts, et cetera. At its basis, the way that I've understood it and the way that I've oftentimes communicated it to students, and again, there are going to be a lot of people in here that have worked in a wider array of aspects of this research area than I have. But for me, machine learning is any algorithm, any model that allows to make a decision, where that machine has a task to make a decision. So thus a linear regression, for me, is a machine. It's a machine learning approach, and you go through a process of having that machine learn something. So thus, machine learning can involve anything as simple as a linear description to something with a multiple layer convolutional neural network, which is extremely more complicated, extremely less tractable and understandable. So when you start to think in the realm of artificial intelligence, contextually, it tends to float more towards this higher level of complexity, whereas machine learning captures, again, for me, the entire gamut of how you train a machine to do something. Clustering, decision-making, regression, et cetera.
Okay, I think I'm going to make it worse before we make it better. Because when I think about AI and I think about machine learning, Kranos was really talking about algorithms and analysis, and I introduced these ideas of descriptive and predictive kinds of analysis. But when we're thinking about how you actually do AI, it's not all about the analysis. And I think a lot of people who work in the AI space really see themselves as working in a broader space. So let me talk to you a little bit about how we might broaden that space. So anything that we're doing in AI or machine learning requires data. And so when we're thinking about data, the first problem that we have is we actually have to generate data. So there's a whole lot of different research going on, everything from how do I build and deploy a sensor? How do I find, how do I discover data that already exists that might be relevant to my problem? So there's that whole question about data generation, and many people who work in AI and machine learning are very much on the data creation kind of piece. But then if you're going to create data, excuse me, you have to store it, right? And so, we're not talking about Excel spreadsheets anymore for most of the problems. We are talking about serious research, compute, and storage. There's a reason why OITA makes 2 terabytes of storage available to everyone, because the scale at which we are thinking about data has really fundamentally changed. So we think about how to generate data, then you have to think about how to store it in such a way that you can use it and you can find it. Okay, well, if you're going to store data, then that opens up some other problems. Then you have to be able to, when I was trained, nobody really taught me how to process something at a 2 terabyte scale. I was having a rough day if I had 1,000 observations, right? And yeah, Heike just laughed at me, right? So we are not at 1,000 observations anymore for many of these problems. And so that processing issue is a huge issue. And more than that, once you're storing data, then you have to worry about how do you manage it? How do you know if it's updated? How do you secure it? So, that's another huge piece of what we've got going on in this AI, machine learning, data science adjacent space. Then eventually you get to the point where you want to do some analysis, and we've been talking about that. But once you do analysis, if you're working at scale, there's a huge question about how do you communicate what you've figured out? And that often leads to questions about visualization. So what's the right picture? What do I use to communicate what I have learned from my terabytes or petabytes of data in a way that it's consumable? And then how do I interpret it? How do I get back to that question about decision making that Kranos was talking about? So when we're talking about, is it data science, is it AI, is it machine learning? Sometimes it's a little broader. Are we talking about sensors or storage or cybersecurity or parallel computing or technical communication? All of those have something to say in this space that we're trying to describe today. So I think many of the folks who are interested in trying to learn about AI, you may not be somebody who's building a better compiler or building a better algorithm, but you may be the person who's helping us figure out what's the most effective way to store this information so that somebody can do analysis, or what's the most effective visualization I can create so that the analysis becomes useful and supports decisions. Okay, I'll get off my soapbox.
Oh, that's great. So I think what you just heard Allison describe is a whole process of data science, from which data are we going to use, all the way to how are we going to manage it and store it, to what is the analysis that we're going to do, to how are we going to communicate it to the audience that we need to communicate it to, and then how even are we going to test it to make sure that what we're doing isn't biased in some way, that we cooked in unintentionally, or that we didn't recognize was happening, so that the decisions we're making are somehow reinforcing something we didn't mean to be perpetuating. So big umbrella of data science that has many, many components. This analysis part of the data is what we usually think of as AI. Maybe we also think about it as machine learning. And in machine learning, you start hearing about more terms. That learning term, you keep hearing in words like deep learning, supervised learning, unsupervised learning. And so these learning terms, sometimes you'll hear neural networks. I think you heard Kranos say neural networks. So these terms all have to do with how you're going about the analysis, and you may hear some of those terms in the lightning talks that we're going to hear today. And so just be aware that each of these things are things, if you are familiar with them, great. If you're not familiar with them, it's not a problem. You can just let that information come through the talks and start learning. What are some examples of unsupervised learning? Supervised and unsupervised learning has to do with how much you are interfering in some sense with the algorithm as it's doing its work and making sure that what you're getting in the iterative process is what you want. Maybe you're going to supervise and interfere a little bit, or you're not going to. You're going to just let the machine work unsupervised. So there's some, again, that's not a technical definition, but it'll get you started in sort of understanding what people are saying when they say supervised or unsupervised. So what we want to do next is really move from this general conversation of what is data science and what is AI to why are you here? It's really important to us over this 2 days that everything we do relate to what you do, and that you leave here with new ideas about how you're going to do what you do, right? You're going to meet new people. You're going to be exposed to new techniques. You're going to know what the resources are around campus to get what you need and what your students need. But we also want, one of the nice things about going to a conference is you have time to reflect. So what we'd like you to do is take a couple of minutes. You can write this down or not. But I want you to think about, where is data science and AI playing in your work, and what do you want to get out of these next couple of days? What do you want to learn? Who do you want to meet? What do you want to think about? So I'm just going to give you a couple minutes individually to think about that. And by the way, I taught in a Quaker school for a long time. Americans are super, in generalization, uncomfortable with silence, but we're going to have some, okay? You're going to get some time to think. 2 minutes. It'll seem like forever. You can do it.
I was going to ask if somebody was going to play the Jeopardy music.
Yeah. Silence. That may be the only time you get 2 minutes of quiet in the next month. So I hope you enjoyed it. I hope you each have a goal for the conference, somebody you want to meet, something you want to learn, something you want to understand, question you're going to ask, or a conversation you want to have. So what do we do, Granos, once we have those things in mind?
So I think that for the most part, what you would find, the things that you wrote down, you'll be able to recognize yourself as being in, 1 in 3 possible areas, maybe more. So someone that is possibly more on the foundational side, someone like Allison mentioned, really focuses on algorithm development, algorithm improvement, algorithm implementation. Someone that's more on the application side, someone that recognizes aspects of artificial intelligence, machine learning, recognizes its uses, have used it in the past, or would like to use it in the future. Or someone that is AI adjacent. So someone who hears all of these different terms, hears things like ChatGPT, wonders, what it means, what does it mean for my kids in terms of how they learn, what does it mean for my students in my classroom, et cetera. So I think once you're able to kind of recognize this aspect, trying to then identify how to relate to others, how to communicate to others, how to communicate the things that you're looking for and the things that you need in terms of identifying collaborations, learning more, et cetera. I've faced this many times over in my area of work, which tends to be more translational on the agriculture side. And you have people like myself who are doing research in this space, and then you have stakeholders, farmers, producers, that see the potential benefits, but really struggle with being able to decipher all of the terminology, all of these nuances that would help them to understand whether or not AI can actually have some level of benefit to them. And then you have the researcher, someone who has lots of information, lots of data, and can get access to almost any package where you can train a neural network. All you got to do is structure the data properly, send it into this thing, and something comes out. But like Dr. Volk mentioned earlier, how do you interpret it? How do you understand whether or not this actually makes sense? How do I even know that the data that I collected fundamentally helps me to address the question that I'm actually going after? This is where connecting with all of these different individuals become extremely important, because then someone that's more on the foundational side can really help to provide that insight. Or for somebody that's on the foundational side, can actually see how their algorithms can be used in applications beyond what they even thought of. So I think that's kind of where we go next, using this common language, this common vernacular, to then identify how you can communicate with others.
Okay, so what we thought we would do, just as a little bit of a preview for some of the talks that you're going to see at noon today, is we thought we would just give a few short examples to help sort of orient you towards some of, the breadth of what we see as the different areas where you might be working in and around AI, machine learning. And so I'm going to start talking a little bit about methods and foundations. And so a lot of times when people start talking about AI, I think they may sort of have in their brain this space. This is a space often of computational and mathematical researchers. Not always, but these are folks whose fundamental work is in developing algorithms. But it's a little broader than that. It's not just algorithms, it's also developing hardware, developing computers that can help you execute things. It's folks who build a better compiler so that you can execute things much more quickly. So when you're thinking about people whose work is in the hardware space, in the software space, in the algorithm space, that's really sort of what we have in mind about methods and foundations. But I'm going to take that just a little bit broader, because I think some of the methods and foundation works also bleeds over into the data side of things. And so in particular, I often think about, these are often called the V's of data. So as we've talked about, data's big and getting bigger. So folks who are helping you figure out how to work with very large data sets, often that's very foundational and can work broadly across a large range of problems. Or figuring out how to work with streaming data, or figuring out how to work with very heterogeneous data types. So, when we were designing an experiment and we would go out and we would collect our 30 data points to answer our question, that data was really all the same. But now maybe I'm working with text and geospatial data and video data, and we have to figure out how to think about the fusion of all of that data. These are the kinds of things that when we're kind of, describing a bucket of some of the work, we tend to think about more in methods and foundations.
I mean, in terms of some of the examples that, you know, I've come across in terms of my work and my research, I think it ranges from the foundational to the more translational and applied. Foundational would be something like tracking gene expression over time and space. So you have, you know, images, let's say confocal images, which basically captures fluorescence. Basically, it's an image. And, you know, you are trying to address and answer fundamental questions about cellular activity at the basic level. So where AI, machine learning, et cetera, can really come into play is being able to actually segment, identify, and track these aspects. Tracking things like root growth in an automated way. Tracking direction of root growth in an automated way. These are, again, other fundamental areas that we've worked on. I think there's also some other more translational aspects, things where information can be extracted and provided to potential stakeholders. We have projects where, for example, we're looking at streaming data, streaming images, where we are, you know, basically segmenting sweet potatoes across a packing facility. And this thing is producing, you know, running really hundreds of thousands an hour of sweet potatoes running through this facility. And no one is going to go in there and count those things by hand. You know, no one is even going to be able to see half of those things. But using things like AI, we can not only quantify them, but we can actually assess things like shape and size, dimensions, length, width, all of these things that a stakeholder really takes for granted. And if you're able to just do that and extract that kind of information and provide it to them in a chart, just to show them the type of inventory that they have, it helps them to make better decisions in terms of planning, packing, forecasting orders, et cetera. So those are things that, again, are somewhat straightforward, but the type of information that can actually be extracted can become extremely important to a specific individual. So these are some of the examples where we've actually seen AI become very helpful.
Great. And so my work has been in industry across a lot of different kinds of applications. So each year I would have a student team. We would work for a different industrial sponsor for a year. And it was interesting to work in the space of a decade when the way we were approaching problems really changed. So an early problem that we had was for an IV drip company that made IV pumps. And they were concerned about infusions when the IV, maybe the arm is under a cover and the IV hasn't gone into the right place and the fluid isn't going in the right place. And if this happens to a child, they may lose their arm. So these are very serious. They happen often. And the question was, our sensors in the pumps are not giving a signature that would set off an alarm that would tell somebody to go look. For some reason, the usual ways that we have of seeing that something is going wrong are not showing up. So could you look at the data that we can get from our pumps and decide, could these data predict an infusion, or are we going to have to put some other kind of sensor in our pumps, which would be extremely expensive, right, with all of the ways that you have to go with a new medical device? We really don't want to do that. So we really want you to find what the signature might be using the pumps that we had. And so our students, the big question the first year we looked at this project was, well, we're in math and physics. Should we use an ordinary differential equation model or a partial differential equation model, right? And a lot of times in those early years, these were and these kinds of physics-based or mathematics-based models are still very valuable. But they were really all that we were doing to look at the problems in those days. That's what we had to work with. So fast forward a little bit, we had a problem for a satellite company. It was very cool to get to go look at the real satellites. And the question was, we have a way of using very standard control theory, linear control theory, to make sure that the satellite orientation is good. If the satellite is off by a fraction of a degree, someone's going to lose their internet, their television, be very angry. So what do? We want to have, you know, fancier ways or better ways of dealing with satellite orientation. Here are the kind of problems that we encounter, but we're also very risk averse, right? We don't want to change what we're doing. And so they knew that there were nonlinear control theory problems around, but they weren't sure that they could move to them very easily. So again, the team of students found a really wonderful master's paper that used a combination of linear and nonlinear theory, where the linear was sort of double-checking the nonlinear control theory, but it's still very classical models, right? Things that have been taught for many, many years. So fast forward again, all of a sudden, every problem we got started looking like anomaly detection. So for example, we worked for, I think I can say this, Microsoft Bing, and they wanted to understand how their internet traffic was, whether it was normal or abnormal in their search engine. And so if sometimes abnormal looks like it's the Super Bowl, and everybody's acting differently than usual, but there's nothing wrong. It's supposed to be happening. And other times they're getting signals that look like they need to wake somebody up and fix something. And so again, they gave our students all of their internet traffic data and asked, can you detect anomalies? And they knew of some anomalies in that data, but they wanted our students to go find them. All of a sudden, they're using machine learning models, right, and trying different models that are out there to see which ones might do the anomaly detection. And then many, many problems. Again, we were hired by another company that was doing some drilling, and they wanted to know, can we drill faster and safer? And can we do that in a way using the signals that are coming in from our sensors? And again, can you detect anomalies that would indicate we need to slow down or that something unsafe is happening? So all of our problems turned into anomaly detection models. These days, I don't hear the problems from industry being couched in that same way. You heard Allison talk about data integration across different sources. And I think right now what you're hearing from industry a lot is we're getting data from here, we're getting data from there. And it could be the same kinds of data from different parts of their company. It could be a company that has many companies and they're getting data from across the company. Could, like Allison said, be different types of data. And so again, the big question is, how do we integrate these types of data to get more insight when maybe they're inconsistent, maybe they weren't collected the same way? And in healthcare data, same issue, right? You have many different doctors. How many of us have more than one patient portal, right, from our different doctors with our different data? And I think in the next few years, you're really going to see a big industry of how do you integrate your own data from across all of your experiences and your Fitbit or whatever devices you use to track your exercise and your food to try to inform personalized medicine. So it's been super interesting to see this shift. And so, you know, we've been asked to predict, you know, what's going to happen 50 years from now, right, in AI. What's going to happen 50 years from now in data science? And it's super hard because I can say that just in the last 5 years, the kinds of questions that we're asking, the ways that we can manage and store data, and the tools that we're using are rapidly changing.
And so something that I think is interesting, if you asked all of us would say we work on AI. You know, and if you're listening to the kinds of problems that we were just talking about, they cover a huge range. You know, and again, we've sort of set up just some initial ways to think about this, which is, you know, in terms of foundations, in terms of applications. The one area that the three of us didn't talk about right here is really in the broader societal impacts around ethics, around privacy, around bias. And we've actually, because that is so important and moving so rapidly, tomorrow at 1 o'clock, we will have a panel where we actually spend the entire hour with a group of researchers from NC State and outside too, with a group of folks, and Ray will moderate that panel, really digging in more depth to some of those issues. But yeah, the other thing that I'll mention is the thing that we will be doing today at noon is we have 4 speakers from across NC State. And we tried very intentionally to get speakers who work on AI from many different perspectives here at the university. And they'll have a longer time than we just took, but they'll each have a chance to really set up their research question and the approach. And again, part of that is we do want to really open the aperture so that the university can see all the different places where AI and machine learning are impacting the work that we are doing here at the university.
Great. So could we have a time check, Laura? And we have how many minutes? We have 6 minutes? Okay, great. So the last thing we want you to do, remember you had that individual time to think about why you're here, who you want to meet, what your goal is. We'd like you to turn to one other person and share something that you're excited about, or something that you're concerned about, or something that you're planning to do next over the next 2 days and in the future. So we'll give you a couple minutes to do that, and then we'll wrap up. All right, we're going to wrap up our conversations. I'll give you a couple seconds. Thanks for talking to each other. All right, I love it that you're still talking. I'm going to wrap us up with this idea of why is AI so hot right now? Like, why is everybody talking about it? Is it just ChatGPT? Is it just large language models? Are there other things? You know, I think we really think that part of what's happening is that sensors are accessible to everyone. We carry them around in our phones. Our data are exploding. I think people are recognizing that they want insight from their data. And so these tools are really promising a possibility of being able to manage the large amounts of data that we're all swimming in right now. And our hope is that at NC State, we really think about collectively how we engage in research and how we think about all of the ethical and human as well as environmental considerations that go around with our decision making around AI.
And I think one of the things that with AI, data science, data analytics being such hot topics, one of the things that we always have to remember is that artificial intelligence is a GIGO system. GIGO meaning garbage in, garbage out. If you do not put good information in there, you're not going to get good information out. If you don't structure your problem effectively, you're not going to get the types of results and answers that you're trying to get. So in really trying to address and integrate some of these things into our research, because they are hot topics in RFPs, it becomes very important to understand exactly how to try to integrate these things. And that means, going back to what we said earlier, communicating across different individuals with varying levels of expertise so that we can really understand what types of tools are best for the problems that we have.
And so with that, we are going to wrap up this opening session. Our keynote fireside chat is going to start in just a minute as soon as Dr. Srivastava joins us. So while we are waiting for him, you guys are going to get a minute or two, grab another cup of coffee, and come back. What we really want to do in this next talk is we spent the last hour or so sort of thinking about NC State and thinking about where we as people at NC State fit into this ecosystem. What we're going to do now for the next hour is really open that aperture again. And it looks like Ashok is joining us. And so we are going to transition and have a conversation with Dr. Ashok Srivastava, who is the Chief Data Officer and Senior Vice President from Intuit. So I'm going to give everybody just a second while we transition. I'm going to let you transition, and then I'll be back in just a minute, and we'll kick off with the introduction, and we'll get started with our conversation with Dr. Srivastava.
And thank my colleagues, please, for this fabulous conversation.
Oh, it's not on this one.
So Ashok, we wanted to check and see if you could hear us if we're using the microphones.
I can hear you very well. Can you hear me?
We can. You are on the room mics, and that's all going to work. So we're going to be another 30 seconds while everybody stands up and grabs a cup of coffee. Then I will start by introducing you, and we'll transition to some questions from Kranos.
Excellent.
So if everyone could start moving back toward their seats, let me go ahead and kick off with the introduction for our, I'm going to call it the Keynote fireside chat for today. So we are just delighted to welcome Dr. Ashok Srivastava to our conversation today. Ashok is the Senior Vice President and Chief Data Officer at Intuit. And in that role, he's responsible for setting the vision and direction for AI and data across Intuit. He is also an adjunct professor at Stanford and a member of the board of directors of the University of Colorado Foundation. Prior to this position, he also served as the Vice President of Big Data and Artificial Intelligence Systems and the Chief Data Scientist at Verizon. And in addition, he has also worked at NASA, where he led the advanced technology programs in aerospace, space systems, Earth and space scientists, Earth and space sciences, including the system-wide safety and assurance technology and integrated vehicle health management programs. So Ashok has a really large range of experiences covering government and industry, and we're just delighted to welcome you here today.
Thank you. It's great to be here, and I am so looking forward to doing this. I apologize that I couldn't come to North Carolina and be there in person, but I am happy to be here virtually and to be of good service, because the reason I say of good service is that I fundamentally believe that the work that happens in academia is the foundation for our modern society. And I want to thank all of you for the dedication that you have in providing society with great education across the board, not just in the STEM fields, but in the humanities, in the liberal arts, in the arts, in music, literature, the foreign languages, all of the areas, because that's what actually builds a society. It's not just built based in one area. So very, very happy to be here, Allison. Nice to see you again.
Thank you, Dr. Srivastava. So I think one of the things that we wanted to do was to really kind of open up this session with some general questions for you. And again, based on your vast experiences, we're really interested in learning and gaining some perspective on your side. The first question is, what do you see as the biggest challenges for foundational AI and AI methodologies?
What a wonderful question. So I've been working in artificial intelligence for a long time. I started with my PhD in electrical engineering, but I started to focus on machine learning and neural networks in particular, and charting how neural networks have developed now over the last many years is extraordinary. And what's happened is that the use cases, the applications of neural networks and of other advanced technologies that are based in other types of decision systems have become ubiquitous, and they're going to only become more ubiquitous as we move forward. I think one of the fundamental challenges that we need to think about as people who are practitioners in this field, as people who do research in this field, is to think about the just use of these technologies. What's the appropriate way this technology should be used? What is the ethics behind it? How is it going to be used for the public? How could it be used against the public? How could it be used to make the world a better place, and how will it be used to make the world a worse place? This is not, notice I didn't say we need better algorithms. I didn't say that we need more powerful statistical methods so we can somehow know these systems better. I think those things are definitely important, and they're very exciting work, and I don't at all mean to minimize it. I'm somebody who has worked in this field for a long time, and I love basic research in the functions of the field of computer science and statistics and all these other fields. But the position that we're in as a society now is that these systems are operating and will operate at a scale that is unimaginable to us. Who better to think about the right use, the ethical use of these technologies than people who are steeped in the ethics of humanity, the ethics of how people should treat each other, how systems should operate in conjunction with human beings. This is, I think, of paramount concern. Now, having said that, I think there are other things that we should look at. I think that understanding how these models can grow and adapt to fast-changing environments, I think is very important. How they can help us, how we can get certainty about the predictions that they make or about the conversations that they have with us, how we can be sure that the algorithms are, for instance, these natural language processing systems, how they're embedded and model the truth, I think is incredibly important, because plausibility that comes out of these systems, these systems can emit plausible information. If you've used ChatGPT or any other these large language models, what they write is very plausible, and yet they are not correct often. And I just saw an article this morning that said that the truth of these systems drops exponentially as you do more autoregression on the system. And for those of us who work in the field, it's not surprising. But for those that consume this, it is completely not intuitive to think of something like that. So these are some of the areas that I would suggest, but really the just and correct use of these systems in our society, I think, is most important, especially today.
Thank you. Thank you for that response. So just as a follow-up question, what are the community of individuals that need to be brought together to actually take those steps?
First of all, it needs to be a committee of individuals. It needs to be human beings. It should not be ceded to machines. Because I've heard my colleagues at other places say things like, well, the way we're going to do this, solve this problem, and I'm paraphrasing here, but I think the spirit is correct. We're going to have systems that monitor the systems, and they're going to tell us if something is biased. They're going to tell us if there's an ethical breach, and it'll be great. We'll have this amazing dashboard, and if there's a little blinking red light, just like that, we will, it'll be cool. And that's not really a far-fetched or an improper representation of the sentiment. That should not be the way we do things. It should be part of it. But humans need to be involved with this first. Second, it needs to be a broad spectrum. It should not just be technical people, so-called technical people, like I've got a PhD in a STEM field, therefore what? Therefore, that means that you are somebody who might know some of the computer science, the statistics, the probability theory, and other things behind that. But the fact is that people in other fields have been thinking about ethics for a very, very long time. For thousands of years, people have been thinking about this, and they're steeped in that knowledge. People need to be working across these disciplines to come up with the right approach to govern these systems. And that means law, that means, I'm not going to name all of the fields, but this is why I started by thanking those of you that are working in the fields of humanities and the liberal arts and law and medicine and other disciplines, to come together with other fields and actually think about this in a holistic manner. Because when we do that, the probability is higher that we're going to be successful. It doesn't imply, in my opinion, that we will be successful, but it implies that the chance is higher. What concerns me is when we say that this is purely a statistical problem that needs to be analyzed through the use of data. That's not the way ethics has evolved. I'm not a scholar in ethics, and many of you probably are. But it's not just about data. Data is an important thing, but it's about the society we want to live in. And that society is not one that's constructed on data. That's a society that's constructed based on what we as a people think is the right thing to do.
Thank you. So one of the things that we talked about in our earlier session were examples, applications where AI have been used and are useful. Where do you see AI solving big, long-standing problems, i.e., what do you see as, in terms of your vision, as the current and future application areas of AI?
AI systems are remarkable in their ability to synthesize information. And they are powerful tools for what used to be called decision support systems. So in other words, a person needs to make a decision and they can harvest information that might have been generated through the use of AI. I think that's an important area of work and one that I think can continue. And the applications of this are across the board, which is incredibly exciting as a person who has worked in this field for a long time, incredibly exciting to see, you know, in all of the fields, in law, in medicine, in finance, in climate change. You know, when I was at NASA, we used to use these techniques for understanding climate change and how that is affecting our planet, and understanding the stars, the solar system. It can be used in a variety of areas, and I say that with a bit of experience because I've worked in many different industries in many different places, and I'm lucky for that. And I'm lucky because the field that I happen to have chosen is one that allows me to span a very large spectrum of areas. The world is different now, though. Decision support is not really what people are thinking about any longer. People are thinking about these systems making decisions on our behalf and having a degree of autonomy that people could only imagine before. What we used to watch on Star Trek when we were kids is something that people are actively trying to build right now. And as that happens, as these systems make more and more decisions supposedly on our behalf, we need to be aware that in some cases it might have produced life-saving medicines, and in some cases it might perpetuate injustices that have been around for hundreds of years.
Thank you for that. So, as Allison mentioned earlier, you've had the experience. You've had experiences across many different industries and many different companies. How do you see AI as impacting the employees, the company, and the customers associated with bigger businesses?
So this is something I think about a lot. And the approach that I'm going to take, that we're taking, is one of augmentation, or what I was calling decision support a moment ago. The idea that these systems can be built in such a way that they complement human faculties and human expertise. I think that that's a good way to go. But I also know that not everyone thinks that way, and I'm not naive in thinking that this is the way the entire society is going to evolve and that AI systems are going to evolve. I do think that there are going to be very significant changes that happen in the larger landscape of employment across the United States and around the world. And I think that this is another place that we need to prepare ourselves. We shouldn't shirk our responsibility and say, well, that's just the way it is, and hopefully people can figure out what to do about it. We, as people who are stewards of this technology, the builders of this technology, as people who are in academia who are thinking about things bigger than what is going to come out next quarter, we should be actually thinking about how society should be transformed in a just and positive way with the changes that are coming. Because the changes that are coming are unprecedented. You know, it's been likened to, I've been thinking, what should this be likened to? And, you know, obvious things like, well, you know, nuclear power and, you know, fission reactions, and you can think of the iPhone moment and, you know, all kinds of things like that. I think this is something of larger proportions than those things, because now the AI is on your phone. Last I checked, we don't have fission reactors in your back pocket, but I bet you each one of you has a phone in your back pocket or within 10 feet of you. And if that's the case, and that thing is powered by something that that the billions of people that use these devices don't understand, that's an unprecedented situation.
So with that, as you mentioned, change is inevitable, and with change brings many different emotions, brings potentially fear, excitement, nervousness, anxiety, all of the above. But yet, this is something that is going to come. So what do you see as being some of the biggest challenges in helping individuals understanding the nature of that change and helping in the overall adoption of AI?
Yeah. I'm going to actually go back a little bit and say that it's true. This is unprecedented times, and it can make people feel uncomfortable. Perhaps even what I'm saying might make you feel uncomfortable. But I have to say that I have a very, very a large degree of appreciation for the fact that humans and society can change and evolve for the positive, and that we can together create a world which would have positive impact on the people around us and on society and on the planet and on the ecosystems in which we operate. So I fundamentally think that that is possible, but it's not something that would happen automatically. It's not something that we should just step back and say it's going to happen because it's always happened that way. I'm not arguing, by the way, that it's always happened that way, but one could think that, things have worked out, life is better, so it'll probably work out again. But to the degree things have worked out is because of the hard work from a lot of people across the spectrum, not just one group of people, but a lot of people working together, arm in arm, have been able to make society hopefully a better place for many people. And that's the way we should work on this together. And I think that when we do that, we will see positive change and transformation. And that transformation is something that everyone should enjoy, at least in theory. And so as we move forward and we think about this, we should look into the past and see, and again, this is why, knowing history and appreciating things that are not STEM is so important. This is becoming more and more important, in my opinion, than ever before, because the understanding of where we have been as a race, as a society, as a culture, as a civilization, is incredibly important. And using the issues of the past, the ills of the past, the way we responded to it, and then thinking about the future is more important now than ever. And that's why I think that the academic institutions now need to be strengthened, and that the students that go through this system need to be really, really well-founded in where we are as a society today and where we were in the past, what worked, what did not, why, and what we're going to do about it going forward.
Thank you for that. So just to piggyback onto that, from these different areas, from manufacturing to agriculture to healthcare to even education, do you see there being any specific areas with more significant challenges in terms of adoption than others?
To a degree, perhaps, but it's one of those things that it's within the noise. And the reason I say that it's within the noise, yeah, there's going to be some things that are more and less, obviously things that affect human well-being, medicine, I would argue finances, I would argue the way we communicate, the way we determine what information goes out and what information how information is consumed. These things are foundational, obviously, and they are very important. But the reason my initial reaction is to say that a lot of this is within the noise is because the degree of transformation that I foresee happening is extraordinary. And that we shouldn't assume that because something is somehow less, seems less important, that it's not going to be changed, because we're moving into a world where there are a lot of unintended consequences due to the technology that's coming to fruition. And when something like that happens, I think it's important to be diligent about it. So obviously, areas which impact human health, human life, the way society operates, obviously those are the most important, and we should put our attention there, but not only there. I think that we should think about things holistically, as only humans can today. Think about things as systems of systems, not just, you know, my world and your world, and I live in California and you live in North Carolina, and therefore, you know, therefore what? Therefore we're separated by 3,000 miles. But really, the real thing is that we're all in this together. As a species, as a planet, we're in this together. And that we need to think about it holistically, as only humans can do today.
Thank you for that. So, and the next question really focuses on what you would communicate to the researchers in the room. So if researchers at NC State and other universities could really solve any unsolved AI challenge or address any unsolved AI challenge, what would be your priorities?
I said it at the very beginning. I think the top priority is the ethical use, the fair use of these technologies, the way we should be stewards of the economy, the society in which we all live. And this is not something that just academics and people in industry need to think about. This is one of the things society needs to think about. What society do we want to have in the future, and how are we going to get there? And I think academia and private institutions and other places play an important role in this. I think that's the most important thing. We need to chart our future. We need to do that in a deliberate fashion. That doesn't mean that we need to impose it on others, but we need to think about it. I'm always struck when I look into the past and I read the foundational documents of the United States, for instance, and I reflect on them, and I think that while the people who wrote them were certainly imperfect, while the institutions that were created weren't perfect, the ideas that were foundational, the idea that we're here, to pursue happiness, I think is a very profound idea. And it's something that we should think about deliberately. And we should think today, what does that mean in an era where people not too far from where I'm standing have made the claim not too long ago, a few months ago, that a large language model was sentient. Okay, so I would say that that building is within 2 miles, maybe 1 mile of where I'm standing today. There are people there who think that. Now, obviously, the powers that be said, no, it's not true and everything, but what does it mean if people who work in this field say things like that? And what does it mean about people who don't work in this field, and how are they going to interpret that kind of comment? And what are they going to think when they're interacting with these systems? And what will children think when they feel that the system is as good of a friend as the friend next door, right? That is where our attention needs to go, in my opinion. And look, again, I love um, the math, the probability, and perhaps some of you are disappointed that I didn't opine on how algorithms should change. But this isn't the time, I think, to just think about that. That's too easy. It's very easy to just sit back and say, well, we have optimization techniques, we have models with hundreds of billions of parameters in them. We've got this amazing computing, so let's think what we can do with it. That's an easy thing to do. What's hard is what I'm talking about.
Thank you. So I'm going to turn it over to Allison to look at some of the other questions that we obtained.
So I'm going to kick off the next set of questions with a few things that came in before through the request, and then I'm going to open it up to the folks who are here in the room. So you've got a minute, but start thinking about the questions that you would like to ask. So we did have a number of questions that came in before your talk, and so let me start with one. And so a headline recently said, AI is not coming for your job, but someone who works with AI is coming for your job. So here at the university, what should we be doing to prepare our students to work with AI in their jobs?
Learn what it can do, teach what it can do, teach what it can't do and why, teach what it should do and why. I think those are the ways I would think about it. I think that we're coming to the point where everyone should really have an understanding of what this is and what it can do, what it can't do, and why, and what we can anticipate from it going forward. Because the fact is, this thing is moving so fast that what we say can't be done today is very possible to be done tomorrow. And so it's no longer static where we can just sit back and say, well, that's not possible, let's not worry about it. We can't do that. We should anticipate that this is going to move with speed. So in a world, in a society that moves with speed, when people actually don't understand the underlying frameworks and technology, that's, I think, where the key should be. And as far as the comment that the AI people are coming for the jobs, I think what's important is to think about previous revolutions that have occurred, the Industrial Revolution and the Internet Revolution. I won't name all of them, but thinking about those revolutions and how society changed. And I would say this is a bigger change than anything that has come before, including those two, by the way.
Okay. So, sorry, I lost my spot. Give me just a second. I got it. So, you've been talking a lot about ethical and responsible uses of AI. So one of the questions that we got is, what can be done in business and in policy to ensure the development of safe and responsible AI?
First, to actually have productive conversations, and I realize that sounds like super high level and everything, but I'm sometimes surprised that well, let me not say sometimes. I'm continuously surprised that people in offices of power actually don't understand the basics of technology. And that is incredibly concerning. So the conversations have to occur, and it has to occur at all levels, not just with lawmakers. They're part of society. In the United States, they're part of society, right? They're elected members to Congress and to other institutions. So it's not just them, it's how we come together and having the conversation. So that's number one. Number two, I think that that investing in educating ourselves and the people around us into how technology has changed, even over the last 3 years, is incredibly important. I didn't say 30 years, in the last 3 years. I mean, we have systems that can not only converse, but they can through computer vision, understand us to some degree, our emotions. They can mimic us. They can create appearances that are virtually impossible for human beings to tell whether or not it's real or fake. So this is an unprecedented time, and that's where I would put attention.
Great, thank you. So I'd like to open up the questions to folks who are here in the audience. So if you've got a question, raise your hand, and Laura will bring you a microphone so that Ashok can hear your question.
Thank you. So I have a question. As a risk communicator, so we all know that we have human-generated technologies that introduce artificial and manufactured hazards, right? So you are talking about incalculable risks and unintended consequences. For instance, if we talk about large language models, one of the prediction in the labor market is in a few years, programmers may lose their jobs, right? So my question is, how do we prepare future generations for future of work when we don't know where they will be in terms of technological development? Thank you.
Yeah. Wonderful, and an incredibly important question. I'll admit that I don't have an answer to that question. However, I've thought about it a lot, because what's happening to me, what's happening in the industry, observe, is not completely unexpected. In other words, I think that many of these things can change. So I've been thinking about it for a long time. I think that going back to the foundations of science, of the humanities, of the liberal arts, of the physical sciences, of engineering systems is going to continue to be important. But doing it in a way where we understand that the AI capabilities that you're describing are going to be omnipresent in those worlds. In the world which you least expect, just expect that it's going to be there in some manner. And so how do you further the human curiosity in that context? For those of us that are curious, again, this is an extremely positive and extremely exciting time, because we will have the ability to get answers to the questions that we ask very quickly, assuming they're correct, which is a big assumption today. So these large language models do not emit correct information, they emit plausible information. But let's assume that they become more and more correct over time. How we stoke the fire of human curiosity in a way that can benefit society, that's where I would put my attention. And I think that the foundations of our society still lie in the fields that I mentioned. I didn't mention all the fields, by the way, but I mentioned some of them. And I think that those are the places that we should continue to invest. And so having people understand engineering systems, computer systems, from the ground up will continue to matter, but their work will be augmented. We invested a lot as a society in STEM research, and I think justifiably so, and I think we should continue to do that. But I think that we should invest much more in the other fields as well. Now, some of you might be saying, well, I've read or I think that in fact, I saw an article yesterday that the need for the English major is no longer there or something like that. I mean, what an unfortunate thought. Because these majors teach us how to do critical thinking, which is going to be more and more important as time moves forward. Not to say that STEM doesn't teach us critical thinking, I'm not saying that, but I would admit that these fields teach critical thinking. You can take courses in rhetoric, you can learn philosophy, you can learn these things, and that should form at least part of the foundation for how we move forward. I think we need to invest more in those areas. And what jobs will come from the combination of all of these, I don't know. But I think that we have to go back to the basics in all fields, not just in the STEM fields, and not in the STEM fields, in both of those areas.
Great. So, are there other questions here in the room? Okay. Give us just a second. We're bringing a microphone to the next question.
Hi, Dr. Srivastav. Thank you for your thoughtful discussion. My question is about some of the things you mentioned about how to communicate how AI works and how that is important, what can and can't be done, what should and shouldn't be done, and why. What are your thoughts on if you could provide a little bit more nuance within that and how that is challenging to communicate? And maybe if you could shed a little bit of light on how that's the challenges within that, both in a context of actively learning, so say somebody who is in a course about AI or who's looking up information about how AI works, and also passively, if somebody may be experiencing an AI system and they, whether it's through a web portal or an application, and they're interacting with AI, but might not know how it works. So could you talk a little bit more about that? So is your
question, I just want to make sure I got your question. Is your question how we should invest in educating those two groups, the people who are kind of in the field of AI and people who are in related fields? Perhaps I didn't catch it.
I guess the distinction I was making was in when somebody is learning about artificial intelligence, so say somebody who's concerned about how their field would be impacted and is trying to learn about AI systems work and how they can apply and use them. So as, I'm not sure if it's the perfect term, but an active learning versus somebody who's interacting with an AI system already, and we have, like you mentioned, we have them in our pockets and there's so many of them around. There's, I imagine, another form of learning when we're just interacting with the systems and gradually figuring out, oh, this is what ChatGPT said to me. I guess this was wrong, or I guess this was right. So how does learning need to differ in those two contexts?
Yeah, that's a wonderful question. I think it's very important that we learn the basics of how to tell fact from fiction. And that might sound like a very philosophical answer, but I really do think that's the fundamental issue. Regardless whether you're in the field of AI or whether you are in another field, whether you are someone who is practiced in it or whether you're someone who is just using it as a tool. And when I say fact from fiction, what are the qualities of something that's factual? How do you know if something is true or not? Well, you know, hundreds of years ago, as a society, we came up, our predecessors came up with this idea of the scientific method as a way of determining whether something is true or not. And the idea of that is based on some sound principles, I think. This idea that you can learn some base information, some basics, that you can then formulate a hypothesis, and then you can test the hypothesis. And then based on that, you can make a decision about whether something is true or not. Now, that used to be something that was just done by humans, and now we might be asking machines to do it on our behalf. What does it mean in that context to make such a decision? And I think that's going to be very, very important. The passive use of technology is remarkable. It shows up on our phone as a web experience or an app experience, you know, and then we find ourselves relying on it. Just think about the map function on your phone. Probably most of you use it a lot, and it came to you probably just magically. And now to figure out how to get from wherever you live to wherever you want to go, it's probably impossible to think of how you used to do that. You know, I wonder how this used to be done before. And I'm actually a good map reader. So that's cool with maps, I guess. I don't know if it's cool, but it seems cool with maps. Those of you in the geography department might differ in your point of view about it. But how that happens when the system is actually making decisions on your behalf, which are consequential, that's, I think, something we need to think about. And the short answer is I don't actually have an answer to that aspect of your question, because the pervasiveness of the technology, as we're speaking, it's going out into the marketplace at rates that we can only imagine. And kids and everyone around us is using it all the time. And so this is a degree of change that we need to think about and manage.
Great, thank you. Other questions here in the room? So we guessed wrong on which side of the room it was coming from, so we'll get the microphone there in just a second.
Okay.
Okay, so applications like ChatGPT have been described as stochastic parrots. So basically they're providing the answer that's most common based on its input data, which is what it's scraped from the web. So one of the concerns I have is that these applications are essentially going to be misconception amplifiers. So I'm wondering about your thoughts about how we create a feedback loop so that the truth or the fact is important and things do get corrected, even if it's not the most common answer on the web.
Yeah, what an incredibly important and insightful question. Thank you for asking. Again, we'll need to have a common understanding of how to determine what's true and not. And in a society like ours, where free speech is not only treasured, but it's the law, we need to think about this, because my truth and your truth might actually be different. How we perceive things might be different. What we value might be very different. But we need to be able to communicate at scale about this. And the scale is very important here, because when I was saying a few minutes ago, I was saying that we should not cede this to machines and just have the machines do it. Well, the fact is that to operate at this scale is going to require machines to do things on our behalf. So I'm not so naive to say, well, just have a committee sit back and, you know, look at what the models say and then make some decision based on that. For certain classes of models, certain applications, that's certainly true. But if you're running a system which has billions of users on it, and billions of people are using these systems in order to generate content, it becomes a very, very different thing, and it becomes an issue of scale. So then the task becomes as follows. How do you determine if something is true or not at scale? And how do you provide that feedback back to society in a way that doesn't create censorship? These are not things that most of the time people in the STEM fields think about. But but we need to come together with people who think about these things on an ongoing basis and come up with answers to it. And I'll point out, though, that while I'm not at all a scholar in these fields, so forgive me if I say something wrong here, but I think that the way we've thought about communications in the past is not communication, journalism, things like that, is what I mean. In the past is not as, it doesn't scale to the degree that we're talking about today. That's, I think that's true. If I'm wrong, okay. But I think that's true. And if it is true, then we totally need to think about it and come up with a plan.
Okay, let me share a question that came in through the chat. And so this is a university research symposium. So this question sort of drills in on that just a little bit. So what do you see are some of the strongest potential avenues for AI to accelerate research?
Oh, so many areas. Let's start with the field of medicine. Now, admittedly, I don't work in medicine and healthcare, and so I'm speaking about it from as an outsider, someone who knows AI but who doesn't really work in that field. But I think that the opportunities of using AI in the medical realm are extraordinary. Drug discovery, in the development of understanding of how the human body and other biological systems work, how these systems evolve, how disease can be treated, how new diseases come up, all of that absolutely I think would be incredibly interesting. To help us understand our own physiology, how the brain works and so forth, absolutely would be incredibly important. How to optimize manufacturing systems even further. So how to create new materials, new capabilities that we can only dream of today, I think is quite possible through the use of AI. How to use AI to generate new scientific hypotheses. This is something that I thought about when I was at NASA quite a lot. So you could imagine that a researcher today, good ones, are familiar with the literature, they know their own field, and then they make a hypothesis and then they test the hypothesis. This is something we've been doing for hundreds of years as people who work in research. Well, what about automatic hypothesis generation from the use of artificial intelligence? That would be incredibly interesting. And then you could imagine that the AI answers the hypothesis that was generated. That's not too hard to imagine either. And I used to think about this in the context of astrophysics in particular. You could imagine an AI system, quote, reading all astrophysics journals, let's say, and based on that, making predictions about what should be observed in the universe, and then directing telescopes to look in that part of the universe, and then doing science by themselves, creating a fully automated system. So those are just a few examples. So some of them that have direct ties to humanity, and some of them that have little tie to humanity, at least today in terms of astrophysics and things like that, but incredibly important. Just because something has no immediate utility does not mean that it's not important. It just means that it's different. And I think that those are some areas. In the earth sciences, incredible use of AI to understand how the climate is changing, how to make better predictions and so forth. I could go on and on, but those are just a few ideas that come to mind.
Okay, terrific. We've got another question in the back. If you will go ahead and speak your question, I'll repeat it so Shou can hear you. Okay, so let me see how well I can repeat that. So the question was, the data structures that are used in AI today often reflect the power structures that are inherent in our society. And one possible outcome of that is to continue to perpetuate some of the inequalities that we see within society. And so as we're looking forward and thinking about data collection and data structures, do you have a vision for how we might mitigate some of that inequality as we're moving forward with the development of AI?
Yeah. First of all, I agree with this statement that that these systems, because of the way they're constructed, based on data that's collected, in a lot of these cases, these are convenience samples, and because of that, they will perpetuate bias and other injustices that have been around for hundreds and hundreds of years. And how to address that? Well, first, we have to be aware of it. We have to be aware of the consequences. We have to develop techniques to identify that. And then we have to build techniques to mitigate it. And this is something that we're investing in incredibly here, as well as I know that other places are making such investments. We need to do all of this, however, in the context of an appreciation and the desire to enable people to preserve their privacy. Because privacy, the world of privacy is changing very, very rapidly. And what used to be thought of as private information is now quite public in many cases, with people's presumed voluntary consent. And so thinking about how bias can be perpetuated is good. Thinking about the sampling technique is important, but then thinking also about what information should we not ask or infer is also very important. So those three things come together in incredibly interesting ways, I'd say, from the research standpoint. But when you're implementing systems at scale, it becomes paramount to think about it and to take the right actions.
Terrific. And with that, I actually am going to draw our chat to a close. And so I want to thank you so much for spending the hour with us today. I'd like to thank everyone who submitted questions online and everyone here in the room who also contributed the questions. And so why don't we thank our speaker?
Thank you. And thank you all for your attention. And I'll just close by saying that I am very optimistic that as a society, as a species, that we can actually come together and solve these problems. We've done this many, many times before. And it requires dedication, it requires a commitment, it requires collaboration, communication across all disciplines, and across a broad swath of society and across nations and across the world. It requires that level of communication and collaboration. We have done it, not always, notably, but we have done it, and I think that's the way we should think about it. We should be optimistic about the future, because with that optimism, we can build a world, we can build a society which allows people to pursue happiness. And that's the direction that we should move, and we should not be pessimistic about these things, because pessimism leads to a lot of consequences that are unintended. We shouldn't be naive, but we should see a future for ourselves that is very, very good and helps everyone move forward, not just a select few. Thank you very much.
Thank you. And so now I would like to turn it back over to Laura to help us move on to the next part of our program.
Thanks, Walker. All right, thank you. And thank you to our special guest, Dr. Ashok. What an amazing discussion that we not only had internal to NC State, but we got to hear that external perspective from Dr. Ashok and Intuit. Special thank you again to Drs. Levy for joining in the initial conversation, and then Drs. William and Wilson for joining our guest speaker in the conversation, talking about these critical elements of data science and AI in our research and what at NC State, what we might need to do at NC State and consider moving forward. So just a note, I know lunch is actually a tiny bit late today, so what we're going to do is have our first highlighted speakers, our first two, go, and we'll take a quick break to start shuttling over to some of the buffet, and then we'll come back and do our our last two of our highlighted speakers today. So with that, we're going to hear from some faculty at NC State. We have 4 highlighted speakers from different disciplines across campus to provide an overview of the research they're conducting and future collaboration participants in the room may be interested in joining. I'm going to ask Dr. Huling Ding to be our first speaker, and I invite her up to the stage. I saw her. There she is. Everyone clap. Sorry. We're transitioning a little rough here. So you can handheld this, and here's your advancer and a water.
Okay, great. Thank you so much. Well, it's a great honor to be here, and thank you, Laura, for the introduction. I'm from English, so it's interesting to see how our guest speaker talk about how English majors should be more in demand, right, instead of being viewed as outdated. So I'll kind of reinforce that. And my topic today is AI and AI across. And I'll focus on future of work and future of education by talking about responsible AI, labor market analytics, and automated hiring. Okay. So how did the journey begin, right? So back in 2019, I got funded as a PI for a large grant on AI and future of work from NSF. And I worked with 3 co-PIs in computer science and 1 in engineering. And our conversations are always like this, right? So we got together every week on Friday afternoons and asked the same question. Why are we here? What are we trying to do, right? So part of the conversation is always I will be saying, I'm not an AI expert, right? Tell me how AI works for this type of technologies. And my co-PIs will always emphasize, oh, you are the domain expert, right? We don't know how to solve your problem. So when we move on to compete for phase 2, they were like, you should be the PI again. I was like, are you sure? So that's the ongoing conversation. And talking about current and ongoing work, I focus more on AI and AI across. For instance, the first area I will talk about is responsible AI and society. Second area, generative AI and communication. That's what I call AI across the curriculum. And then the third and fourth area deals with real-time labor market analytics, right? Future of work. And the last one that I focus a lot on is related to AI and HR technologies. So people, how are they hired? How are they recruited? How are they ranked and matched, right? So what I call that AI and society and AI across NC State. So responsible AI. This project was funded by Google and the National Humanities Center. And we had a really diverse cohort from 15 different universities representing a wide range of disciplines. And together we are developing our own version of responsible AI for undergraduate class, and I'll be offering that in the 4th semester. And my approach is to look at the AI life cycle and identify possible points of ethical intervention. AI ethics, right? How AI impact different populations differently and what kind of disparities are created in the process. That's my main concern. And here's a quick overview of my class. And as you can see, we do a lot of critical analysis, looking at different sectors and how AI influence human society. And then the second area, in terms of writing across the curriculum, I'm working on along with a lot of colleagues across campus and in other universities deals with large language models, right? I was challenged as a writing professional, writing instructor. I think it's Ray, right? You said you have the calculator for writing today. And that was actually the metaphor I used in one of my community engagement talk as well. And today we talk about large language models as all kinds of revolutionary things ranging from smartphone to internet, right? So what I'm interested in exploring is, what are the cultural perceptions and what are the policies, right? How do we navigate the policies? For instance, if we look at academic policies, we focus mostly on how do we prevent students from using those technologies, right? It's plagiarism, it's cheating, it's academic misconduct. But if you look at the corporate world, it's embraced, right? It's welcome, it's promoted as efficiency booster, as productivity tools. So my question is, how do I prepare my students from academic misconduct to efficiency promoter, right, when they move on to the job market? I think those provide us with a lot of profound questions to think about. And how can we teach that in K-12 settings, for instance? And then the next project I've been working on focus on future of work, right? And the proxy for that would be real-time labor market analytics. So if you look across the service providers or the vendors, the biggest one was Burning Glass, and I call that ChatGPT for job ads and resumes, because Burning Glass started to scrape the web, right, for resumes. It boasted of 1 billion job postings, and it purchased or mined a quarter billion resumes, right? So how can we use that data for future of work? The type of analytics I've been working with include skills, job postings, programs, resume analytics. And we can use it for all kinds of things, right? Like program evaluation, program development, curriculum update, student excellence, and student professionalization. So here's a project that I'm currently working on in terms of AI across NC State as a provost faculty fellow. So I've been exploring real-time labor market analytics for career and learning pathway mapping. And I collaborated with a wide range of graduate programs from physics to electrical and computer engineering, and I'm currently working with quite a few divisions, associate or vice provost in HR, instruction, enrollment, and student service to see how we can use this type of data analytics to better teach our students, to map out career pathway for faculty and staff. So that's something that I'm excited to work on. And then possible applications that I see possible use in funded research deals with graduate and undergraduate education, right? And looking at careers in emerging fields and technologies. And the last area I've been working on, which hopefully will be my second book, deals with automated recruiting, so AI decision-making in hiring. Right? In traditional hiring, we submit resumes, human beings read the resumes, we got interviewed, right? We get an offer. But today, AI is doing everything, almost like a preliminary, right, screening in every stage. So we have automated resume screening and job and resume matching. And then you get invited to have automated video interviews. And then, online social profiling will be done to see if we have any inappropriate information online in terms of surveillance, right? And a quick example, talking about critical, right, analysis. So if we look at automated video interviews, for those of you who are more in AI and data science, there are different technologies available, right? I keep telling my students, the lower end will use facial recognition, readily implementable technology, right? That look at your engagement with the camera, right? Your face movement, gestures, and then the middle range will be using voice recognition. Do you sound excited, right? How about your intonation, volume, right? And then the most expensive one will use transcription to do natural language processing. Do you really talk about the skills that the job is looking for? So if we look at those technologies, right, what are the possible issues? You think about image recognition, right? Darker skin tend to be having a harder time in passing those automated interviews, according to my students, right? And then there are issues of access. Do we have good lighting? Do we have a clean background, right? What about high quality video cams, right? And internet connections. So it's a problem of access. Sorry, and then there's the accent, right? So what are the critical issues underlying those problems? We have class, race, ethnicity, disability, right? And then access. So what's next? I'll end with future directions. So I really hope to have that type of work in terms of AI across curriculum, both in terms of responsible AI and communicating with AI and using AI-generated content in a responsible way. And then the second area of research I hope to work on deals with AI across campus and AI in K-20 settings from kindergarten to graduate school, right? How do we use real-time labor market analytics? And how do we teach AI literacy in STEM education? And the photos are from Midjourney. Thank you.
Does anybody have any questions for Dr. Ding? Quiet group. Oh, right.
Thank you so much for that. I was really interested in the disability category because I was thinking immediately of autism, you know, people who may not make the facial gestures that are being anticipated in the, you know, or who had maybe cerebral palsy and would make different facial gestures. So if you could talk about other areas of disability that have been interesting to you and, you know, that play into this space.
Right. So in terms of disability, I think you are absolutely on target when you talk about autism. So when people can't engage with the camera, right, that's a huge disadvantage. I was working on the project, and for the NSF project, we have a team that focuses on ADHD and autism. And when I told them about the technologies, they were so scared. They were like, our kids will never pass that. And they were actually working on our AI tool to help those individuals affected by autism and ADHD to engage with human beings, not to say with camera. And then there are applicants who may have speech impairment. You know, how can they pass that voice recognition stage? And then we also talk about, you know, like foreign students, international students, right? People who speak with accent. If we move on to both voice recognition to natural language processing, if what you say can't even be transcribed correctly, how can you pass that preliminary screening, which is now today required for over 60% of qualified candidates. It's not like the last round of interviews for top 10 candidates. So it's very, very influential in terms of accessibility and equality issues. Thank you.
One more.
A follow-up to the previous question. At the same time, what you're talking about is really limitations on vision of what can be done and limitations on the technology. Doesn't the same technology offer the possibilities of being able to interpret information for people with speech impediments or who don't look at the camera well?
Right. Is that a question or a comment?
Well, do you agree? I mean,
I
isn't it
agree.
an opportunity to
Of
actually
course.
address those things
Yes, yes.
recognizing the present limitations?
Yes, yes. If that's a question, that's a great question. Because typically I will talk about the policy implications of those technologies. And a few states actually, had passed laws to regulate the use of those tools, including, especially for facial recognition, because it's probably the most problematic, right? When you look at your candidates and their skin colors may influence the video interview outcomes, right? So for instance, the state of Illinois actually passed the act in late 2020, basically saying if you invite your candidates to do automated video interviews and you use facial recognition, make sure that's explicitly stated, and you need to have a consent form from the user. And you need to have a follow-up statement on how my video interviews gets used, right? Will it become a part of your training data to feed your machines again, or should it be destroyed? And then because of all the controversies surrounding facial recognition tools, eventually the largest vendor in the marketplace, which is HireVue, dropped facial recognition after stating repeatedly it's quote-unquote objective, value neutral, right? It's objective, we don't have any bias. They dropped that and basically saying something like, okay, we recognize there are limitations, we'll focus on the actual language instead. But there are technologies out there using facial recognition, low end. So if we are moving on to video interviews, I think it's really important to know what technologies are being used to evaluate my performance.
Thank you. Okay, next up we have Dr. Tiffany Barnes from the College of Engineering. If I can get hers. There we are.
Hello, everyone. How are you doing? Good. Thanks for having me here today. So I'm going to give a little bit of a different focused presentation, a little bit more on my research and how we use data a lot and AI technologies for education. And I'm going to try to highlight some of the issues that are related to some of these more general things, like sort of like what can AI do and what can it not do, and what do we spend years doing with our data, trying to make it so that we can do what we think is good for students. And I think it can translate to some of these other environments, like what should people do when they're trying to find people for jobs and things like that. All right, so most of the work in my lab's called Game to Learn. We use computing and artificial intelligence, games, and analytics for improving education. So sort of everything we know in computer science, we try to apply it to use for educational purposes, improving them for individual students. And I also always have to acknowledge in my talks that none of this would be possible without all of the students and staff that work with me on these projects. So I'm just going to give you highlights of a few of the kinds of projects that we do so you can get an idea of where I'm coming from and how long we've been doing this. So here's an example of a project called Concert, and it takes data from all the different educational systems that students use and tries to put them together in a system so we can do AI to help improve student experiences and also improve teacher insights into what's going on in a classroom. So let me ask you a question. How many of you are professors first or teach a class? Great, excellent, okay. Now the rest of my questions make sense. All right, how many of you use sort of Moodle or LMS? Raise your hand. Anybody not use those? Okay, good. All right, how many of you use an external tool, say for a question and answer forum, like Piazza or some other tool like that? Okay, some. How many of you use any other tool for students to do like specially tailored exercises for your course, like maybe some other assignment turn-in tool outside of Moodle? Anybody? Okay, not so many. Well, in computer science, we tend to use about 5 tools per class. So we use Moodle, and we also use like Piazza for a question and answer forum. We also use tools for students to write programs and turn them in, and tools for implementing tests for their programs, and tools for them to get to office hours and get help, because we like to make tools and we make everybody use them. And this is overwhelming for students, you can imagine, right? I don't know about y'all, but whenever I try to learn anything outside of work, if it has me do more than 2 things, I'm like, I'm done with this, I'm not doing it. And students feel the same way. So the goal of Concert was to orchestrate all of these tools together to help students manage all the tools they have to get to do all their assignments, but also for us to get insights on like what are the challenges of people using multiple tools to learn, and help people get insights, instructors especially get insights on how they can help the students manage all these different things they need to do. This is based on a project that I did years ago. In 2012, we had a project to take data from all these diverse systems that we use in computing classes and try to do AI on them to tell like what kinds of interactions can we tell are beneficial for students in the social question and answer forum, and how those relate to performance in sort of our, homework tools. And it took us 3 years to do that project, and almost all of it was to get all the data together and related and lined up. So that's like a big challenge for AI and anything, is to like take the data in this system and the data in that system, line them up and use them together. And then when we have FERPA requirements on top of those, it makes it harder to do those, partly because everyone's nervous, like, what are we going to do with this information when we take it out of this system and put it together with information in that system? But also because it's just hard, because everyone who makes a system makes the data so it can do what they need it to do, not what anyone else cares about, not even the students, right? So, for example, do your students have great tools that tell them how they're doing in their class? Anybody raise your hand if you think your students have great tools to tell them how they're doing in the class. Don't you think they should have that? Anybody raise your hand if you think they should have that? Oh, see, good. That's what I want to make, but it's super hard. And wouldn't you like to also, do you have tools that tell you how your class is doing? No. Wouldn't you like, raise your hand if you'd like to have that, right? All the data exists in our systems, right? All the data that could help us be better is there, but there's not tools to help us visualize it and figure out what to do about it. That is hard. Like, we need AI to do that. But the AI systems that we're talking about today, many of them are based on large language models, which have nothing to do with educational data and how we should use that to figure out how to make our teaching better, how to help humans do tasks better, like do their homework better, or any other kind of task. This is the kind of work that I focus on. I'm just going to skip some of the slides. This is a screenshot from one of the homework tools that I made for my discrete math class for doing logic proofs. Anybody remember doing proofs of any sort in any educational system ever? Raise your hand if you remember doing proofs. It's usually traumatic for people, and most people remember it. Like geometry back in 6th or 7th grade or 8th grade or something. And some people are like, oh yeah, I remember, yeah, now I remember I had to do that. So I built this tool because it was the most stressful thing students had to do in our discrete math class. And discrete math is required for every electrical and computer engineer and computer scientist here at NC State. So it was like a big bottleneck for classes 20 years ago when I was doing my PhD. And ever since then, we've been building intelligent tools that help figure out when students need help. So I want to ask you a question. Do you think people who need the help the most realize it? Raise your hand if you think they do. Raise your hand if you think they don't. Yeah, actually that's true. So students who need the most help are the least likely to ask for it. And so that's what we do in our system, is we figure out who needs help and then we go ahead and give it to them because they don't ask, right? Self-regulated learning is a high-level skill that only your better students have. Figuring out, like, how am I doing? Do I need to get some help? That's a skill that the students don't have, but we can build AI to figure that out. That actually can say, how are you? How is that person doing? Do they need help? Yes, they do. Here, let's give it to them. This is the kind of AI that we make. This is SnapClass is a tool we built that is also trying to pull together data, but from students in K-12 writing programs, and I do projects to train teachers to teach computer science and AI to younger students, And then when they do, they're really nervous about it because they just learned it, and then they're teaching it to their students. Their students are using new tools, and so they need some tools to help them give the feedback. So this is just another example of a system we're trying to build to help teachers manage their classes and get insights about how people are doing. So let me give you also just a little brief dive into one of our projects. So like we're seeing, like large language models have lots of potential and are used in many, many ways. Here's an example of like where we're trying to use data for good. So when someone's doing something online, anything you've done for your class or whatever, wouldn't it be great if you could tell when people were struggling or making progress, right? Now, as a person, most of you are instructors and you're teaching classes, and you can pretty quickly, if you dive in and you see what the student has done so far, how many of you think you have a good sense of how they're doing? I'm assuming since you're human and you teach, you do. So I'd like to see a lot of hands up. Like, if you see what people have been doing so far, can you tell how well they're doing? Yeah? Okay, some of you, maybe you're not feeling so confident about that. Maybe it's because your systems don't have much data and they don't tell you very much about what people have been doing. But I'm assuming, like, think of, like, you know, someone's been working some problems on paper and you look at that. You know, you should be able to tell, like, hey, what, are they going to be able to finish this? Are they on the right track? How long have they taken so far? For example, right, when I make a homework assignment, I'm thinking this should take 30 minutes to an hour for students. I've got maybe 20 problems. That means that each problem should take 1 to 2 minutes, right? Basic math, right? This is an example of super basic AI that we could do on assignments to say, hey, I could just keep track of what people are doing, and if they haven't made any significant progress in a minute or two, they're not on track to be done. Have you ever been in your office hours and a student came and said, I spent 12 hours on this homework? Raise your hand. And I fell on the floor the first time I heard that. I mean, because I'm like, I don't want you to spend 12 hours on this, because I got a lot of other stuff for you to do with the rest of those 12 hours. You should have spent 5 minutes, and if you, or maybe 30, and if you didn't figure it out, you should have come to office hours or asked a question on the forum, because like I said, you have other things to do for 12 hours. So students don't know when they're wasting their time, but there's basic small things that I hope we can do. So this project is an example, and I don't have a lot of time left, so I'm gonna just skip through some of this, of how we've done this, looking for struggling moments when students are writing programs. So this is 2 assignments we had students do. So if you look on the left side, students had to draw this spiral shape using a short program, and the solution, the short program that writes that, is on the left of that diagram. And on the right, the code is for writing a guessing game, and this is all the code for a guessing game. Like, I'm thinking of a number. You guess it, and I tell you if it's correct. And you just repeat that until the person guesses the right number. Like, I'll say, I'm thinking of a number from 1 to 10. And so the program is just, do that interactively. So these are 2 relatively small programs, but students struggle a lot on them because these are 2 of the first programs they have to do in our intro programming class. All right, so the idea is we wanted to figure out, well, what does progress mean when we're solving these problems, right? One difficult thing in here is that these programming problems, you can do them lots of different ways. Like, I showed you code that solves a problem, but there's also about 1,000 different ways each of them could be done, or more than 1,000. It's sort of like writing an English essay, right? You say, write me an essay that tells me what a scroll looks like. You could write it many different ways, and many of them could be correct. So it's actually impossible for us to tell if the student has done something exactly correct. So what we do is we actually check what they've done against some existing prior solutions from students, and we say, which one are they closest to? Well, they're probably doing, thinking like the student who made the one that they're closest to. And we're going to calculate a similarity metric and say, okay, how close are they? And then we do that every time they add new code to their solution. We compare to previous solutions and calculate a similarity score, which is sort of like, how close are you to something that's correct? We give it a score, and then we do some math, so sort of like some AI stuff to it, to figure out, like, these are the sequential scores of people's programs, and we calculate whether they're making progress. So the blue line is like, how close are you to something correct? And when it gets all the way to the right-hand side, then they are done, and they're matching something really correct well. So we figure out their similarity scores with previous things. We figure out how much progress they're making. So we look at the progress score between consecutive tries of what they're doing, and we're sort of getting a slope of like how quickly are you progressing. And then what we do is we say, hey, now let's order all the progressing, like between 2 consecutive steps that students did, let's figure out how much difference in progress there is, and then put all those different progress numbers on a scale, and we'll say any amount of progress that's higher than the 25th percentile is a reasonable amount of progress, right? Because when you're teaching a class, you have bell curves, right? Most of the students can do most of the stuff, so 75% of them are probably doing fine, but the bottom 25% are probably not making enough progress. So we said that's what we call a significant chunk of progress. So that's just some amount of score difference between 2 consecutive snapshots. And then what we said is, hey, how much time does that normally take? So everybody's assignment trace what they did over the course of the problem solving. We look, how long did it take for you to get that numerical score difference? And we call that a chunk. And we break everybody's programs into chunks, and then we see how much time did each of the chunks take. And as long as the chunks took less than the top 75, top 25%, so if they're 75th percentile and below on how much time it took for them to get that much progress, they're making reasonable progress in a reasonable amount of time. So how does this end up for this? It ends up that actually between 1 and 2 minutes is a significant amount of progress. Going back to my initial estimate, 30 to 60 minutes for this. Most of these programs are like 20 lines, so they should make some progress in 2 minutes. And they should be adding about a couple of lines of code every couple of minutes. So we were able to do that, and then what we did is we asked whether or not, we automatically rated this, right, what students were doing. And we said, is this right? And we had experts look at those, like I just asked you, can you look at what students have done so far and tell how they're doing? Would you help them at this point, is what we asked. And we had a 77% agreement at the very minimum with all of the chunks that we did, looking at progress and struggling chunks, which we thought was pretty good because that's more than the 2 humans agreed with each other. So this is just an example of one of the ways that we can try to use AI for taking an intuition like, hey, my assignment takes an hour, you should, there's 100 points, every few minutes you should be making 5 points, right? That's kind of the idea there. We can make AI for this, but this is like, 1/3 of a PhD. I'm hoping we can get the AI there so it doesn't take 1/3 of a PhD to do this kind of thing, but also that we keep the ideas that many of you have brought up of equity and fairness in there while we do it, so that we understand when we do these kinds of things that we're not disadvantaging anybody from specific groups. And I like to say this kind of approach can be used to help like 80% of the students 80% of the time. We still need to be human and help the other 20% the rest of the time. But I'm hoping that we can use AI for good. So thank you.
Okay, thank you, Dr. Barnes. I don't know if we have time for a question, but I think you will be here the next hour or so. So I am going to quickly have a break real quick between our highlighted speakers, and I'm going to ask the group we're going to go over to lunch for a buffet. There are 2 sides of the buffet table. Please use both. If you are somebody that asked for a vegan meal, please come find me. I have a couple of those set aside. So I'm going to ask, I guess, the closer side. Everyone break. Yeah. Remember, there's 2 sides of the line. I'll have the caterers just pull off the tops, but it's all ready to go. And then, again, find me for a vegan meal, and maybe in about 10 minutes, I'm going to ask our next speaker to come up and start his presentation. All right. I know we were getting into conversations, but we still have 2 more highlighted speakers to speak today. So as our next speaker, I'd like to introduce Dr. Bill Rand. He's from DePaul College of Management. So Bill, I'd like to ask you to take the stage and take us through your presentation. And do you want a handheld? Or?
I can hold it.
Okay.
Yeah.
You can come.
Yeah, I got it. Hi, everyone. So my name is Bill Rand. I am in the DePaul College of Management. I'm a professor of marketing, and I'm also the executive director of the Business Analytics Initiative, where we try and work around any kind of business analytics problems within the DePaul College, but also we work to reach out to other organizations on campus to work with them on potential applications of analytics to problems that they might be having. And for instance, we're working a lot with the Data Science Academy on a new undergraduate certificate potentially in that space. So I'm going to talk today about a variety of the research that we've been doing using AI and machine learning and data science techniques within the space of business analytics, but specifically in an area that I spend a lot of time on, which is adversarial social media. So misinformation, as we all know, is fairly rampant out there, right? There are conspiracy theories that have existed forever, right? The earth is flat kind of theories have been around for a long time, but they're growing more and more, and part of that's due to the rise of social media. However, social media can also be a force for good. It kind of allows us to listen to voices of people that we might not have heard of under traditional media formats. And so I'm very interested in how do we make social media better for the world, right? And just to kind of give you some examples of the different theories out there, right? There's of course, all the election conspiracy theories that exist. There is the pandemic and all the conspiracies around COVID-19. There is it's going down all the way to the fact that the metal strip in face masks might be a 5G antenna that's transmitting your location to everybody in the world, right? All the way down to meme culture and how memes can kind of exacerbated the spread of misinformation. And of course, we see one of the things we know about conspiracy theories is that if you believe one conspiracy theory, you are more likely to believe other conspiracy theories, regardless of whether they are related to each other or not, right? So there is a big interest in kind of combating the spread of this misinformation and kind of understanding where it's coming from and how it's translating. So how do we fight misinformation? How do we combat misinformation? There's a number of different ways that have been identified. First of all, we have to identify it, right? We have to identify that this is misinformation. One of the things that I think we should be proud of as a world is that there's increasing emphasis on identifying misinformation in our K through 12 systems, right? And how can we empower some of the tools that they have in that space? We can start to educate our users about, or educate citizens about what misinformation is. So there's a number of different games out there that have been shown to help you identify misinformation by taking you through the process by which people who are trying to spread information do it. So this one is called Get Bad News. There's one called Harmony Square that's out there. They're all trying to inoculate people against misinformation by providing them a taste of it ahead of time. We can, of course, also just increase positive information, the correct information's presence on the web. As we all know, we never scroll past the first page of Google results, and so if we can push misinformation to that second page of social media findings, we can basically erase its existence, right, to a large extent, right? And the reason why I put this Nickelback Rocks, this is kind of a joke, but in my digital marketing class, I often talk about how to provide good information about your company, and I point out this video. If you ever type in Nickelback Rocks, the band that many of you may have heard of, you get this video of people throwing rocks at Nickelback, right? That's probably not something that band wants to see out there. The best solution, I would argue, is to have a lot of your fans post positive comments about how Nickelback rocks, and we can do the same for misinformation. There are also interesting things we can study for ways that social media companies are attempting to combat the spread of misinformation. So, for instance, Twitter a while ago started adding a little, do you want to read this article first before you can retweet it, right? It doesn't force you to read the article, it doesn't force you to click on the link, but just that little additional hindrance or speed bump has resulted in a decrease in misinformation on Twitter, at least for a while it did. We'll talk about how recent administrative changes may have overruled that. But these kind of small things will force people to reevaluate misinformation. Right? So in general, I'm interested in what I would call information diffusion. How do people find things out? What do they do with that information once they have it? How do they decide to pass that information on to others? And in particular, how do modern social media channels and communication channels affect our ability to do that? So just giving a small highlight of projects we've worked on in this space, we did some work with Anna Maria Steiku, who's in the statistics department, and one of her students, Anthony Weisample, and then one of the current students, Xiao Champon, looking at how we could identify bots on social media. A lot of the traditional approaches to bot identification have to do with looking at the networks of how the bots integrate with each other, how they act to each other, what kinds of content they're posting out. But one of the fundamental truisms of a bot network is that if it's going to work, it has to act in a coordinated fashion, right? And so really what it turns out is that if we start to look at the time signatures of when bots or when users are posting on bot networks, right, that they tend to be coordinated. So this is an example of genuine users who weren't bots, and this is an example of a whole bunch of bots acting together. And as you can see, there's a very different pattern of their activity of just when they post. One of the nice things about this method is that it's much easier to find out when someone posts than it is to find out things like who they're connected with on a social media platform. So as a result of that, this technique is a lot more lightweight than a lot of the traditional approaches out there. Another example that we've looked at is modeling influence pathways. This is a joint project that's funded by DARPA that I have with the University of Central Florida. And again, a couple of my students are working, Xiao Champon, again on this one. And then 4 undergraduate students. And one of the nice things about being in the BAI is that we work with both undergraduate business students, but undergraduate stats students, undergraduate computer science students, and we bring them all together to work on kind of these interdisciplinary type problems. So in this one, we're specifically interested in understanding how misinformation is spreading from users to users and platforms to platforms on social media, right? And so we've built up a kind of overall architecture where we label different stories that are spreading as whether they're trustworthy or from trustworthy sources, untrustworthy, and fringe and mainstream, and then we track them through a variety of different platforms. And we try and understand what's going on in the space. The goal here is to eventually provide a tool so that an analyst could go in and see where that information is coming from, where it's going to, who's the key propagator of that information, where is it, which platforms is it likely to hop to next, where is it going to go from here in many respects. This allows for early warning and understanding of this misinformation, and we're using a variety of techniques to explore this, everything from information entropy methods to deep learning approaches to simple vector autoregressive models from statistics, right, to try and explore everything that's going on here. Using some of those techniques, it's kind of funny because you know how there is how we do science and how we present science, and I actually put the first one there because it's more of how building that network of misinformation was very important. But in reality, we actually did this project first. We had an early technique for building that network based upon information transfer entropy methods. And we used that to simulate the spread of misinformation on social media. So we were involved in a 4-year project with DARPA called Social Sim, where we built a model that predicted, for instance, the number of posts on Twitter for a particular hashtag a week ahead of time, right? Or 2 weeks ahead of time, or 3 weeks ahead of time, right? And we could use this to try and understand if there was an upcoming event, what was likely to happen on these other platforms. The tool could also be used. One of the interesting things is once we built this tool, and we used a technique known as agent-based modeling, which is something I've done a lot of work with. I have a textbook in that space. And we used the agent-based model to actually explore cognitive and behavioral limitations of human beings that might be affecting the spread of that information. So this is kind of a cool side project. We could kind of explore, for instance, how many social media messages does it seem like a person is actually paying attention to when they decide to respond to other messages? Because we can monitor all the information coming in, model and simulate what messages they take action on, and then model and simulate how they decide to pass that information on, right? So even though the model was built to really explore this misinformation spread, it turned out it also was generally interesting for exploring notions of how we should better design social media platforms to help information be processed more efficiently by human participants in the system, right? Of course, we've taken all this and we've also used it in other methods. I wanted to kind of emphasize, it's not just about necessarily misinformation spread, but also understanding how people are talking about events in general, right? And so I did a project with some researchers in the UK a while ago where we grabbed a bunch of data around major weather events, right? And labeled those events as whether or not they were talking about climate change in a traditional fact-based way or in a hoax-based way, right? And we explored how the different events that were going on, Hurricane Irene, Hurricane Sandy, and Snowstorm Jonas, how those were related to the political events that were going on at the same time. So did, for instance, the fact that there was a US election going on in 2012 affect the discussions that were happening in that platform? And of course, what we found was that it did, and that there was this hoax characterization that seemed to be increasing in its conversations over time. I did want to, I don't want to use up, I know I'm running out of time, so I did want to mention, I do a lot of work that's interdisciplinary, but I do actually do work that's in marketing, since I am a professor of marketing, so I wanted to spend at least some time talking about things that we're thinking about within the space of marketing in this space, right? So a recent paper that I've been working on is how do we use kind of language models of how people are talking online to make recommendations to companies about how they should respond to social media comments. So as you might know, consumers are increasingly interested, and many of you have probably done this yourself, about complaining about companies and brands in a social media space, which is great. It gives consumers power. It gives them the ability to kind of take back some of to be a little bit more equitable in terms of the power distribution between consumers and companies and organizations. But firms obviously want to be able to lead their consumers to a good solution rather than just leaving them angry. And I think all of us want to be happy with the companies we're interacting with rather than being angry at them all the times, right? And so what we've been doing is modeling, I think now it's at 10 years of conversations with the 4 major US banks, 4 of the biggest US banks, and exploring what kinds of comments did they make that were received positively by the consumer who was interacting with them, and what kind of comments did they make that were received negatively. And we were able to graph this into kind of angry content. Angry content is when you're very negative and very excitedly negative about it. Sad content, which is you're not happy with the company, but you don't really care too much either, right? Satisfied content, you're positive about the company, but aren't going to recommend them to anyone. And what we call excited content, which is when you're very positive and very excited. So this is kind of sentiment versus valence in some respects that we graphed for all these. And we were able to show how the company could respond using words that were positive or excited themselves, were similar to the topic the consumer did, or were more subjective or more objective. And in using those 4 dimensions, we were able to provide guidance to how you should respond to a conversation that's in any of these 4 categories in order to move people towards the more excited, positive kind of aspect that you would like to see. So that's a brief overview of a bunch of different research topics that we've looked at, and I'm happy to answer any questions if we have a few minutes.
You might only have one. It is a question. I thought it was, I saw a head with wolf bites.
Yeah, maybe this is off topic, I don't know, but if another company like Cambridge Analytics was out there trying to do social biasing using the same kind of approach. Would we be able to know or detect that right now with the tools we have?
That's a great question. I don't think it's off topic. It is definitely in the range of something that we're looking at. Yeah, I would say that, I don't have a confident answer that we would definitely be able to detect it. I would say that right now. Our ability to detect the use of, say, sock puppets and other bot approaches has improved considerably since Cambridge Analytica. So if they were amplifying that message, we'd definitely be able to detect that. Whether or not, if they were just injecting a messages straight in to manipulate consumer thought and sentiment around a topic, that would be difficult to detect right now. And I don't know if we have a great solution. But I think that's an open area for research, and I'd love to spend more time in that space for sure.
I think that's all we have time for questions, but thank you, Bill. Thank you. All right, our last speaker today is Dr. Josh Gray, coming to us from the College of Natural Resources. So I will ask Dr. Gray to take the stage.
Thank you for being here, and thank you for the opportunity to join you today, and sorry for interrupting your lunch. I'm a remote sensing scientist, and my lab spends most of our time using time series of satellite imagery to try to figure out how things are changing on Earth. So things like you see here, which is the advancement of the growing season. So this is as the Earth greens up and greens down throughout the seasons from one of the types of satellite sensors that we have. Before I give you a little snapshot of how we're using machine learning, data science, AI in our work, I want to make a case for remote sensing. Maybe this is your first time hearing about remote sensing. I'm talking in particular about satellite remote sensing here, so satellites that have telescopes. Instead of pointing out at the galaxies, they're pointed back at Earth. It's been transformative technology across a number of disciplines for a number of reasons. The first, and probably the most important, is it provides you frequent, consistent measurements everywhere. So you want to measure the same thing everywhere, wall to wall, and you want to do it every day, remote sensing's got you covered. There's no other technologies that allow you to do that. So it's a really important scaling technology. We measured some things at these locations. What is it like everywhere else? So remote sensing, there's a whole swath of research that's dedicated to that, and it's transformative just in doing that. Beyond that, it offers new ways of seeing things. We can make measurements from orbit that we can't make on the ground. It doesn't matter how many graduate students you can send out to the field with Biltmore sticks. You just can't measure things like how much water is there, half a kilometer under the ground. Well, that's something we can measure with gravimetric measurements from space. So it offers us entirely new modalities of making measurements that are transformative in a number of different disciplines. And the more recent development that's transforming things outside of remote sensing science is that remote sensing scientists have gotten our act together, and we've democratized the data. So most of you are not caring so much about the surface reflectance in a narrow portion of the electromagnetic spectrum, but you do care whether that's a field of corn or an open field of water, or how many leaves are there, or if the lights are on at night and things like that. So we've gone from making those measurements into products. Things like land cover, how many leaves, nighttime lights, deforestation products. These are all products that any sort of data scientist could download and use directly without having to have remote sensing background. Now, and this is the stuff that's been enabled simultaneously by advances in AI, particularly computer vision, and high-resolution satellites, which we have had for a very long time, but we haven't had very many of them, and most of us haven't been able to get the imagery. But now we can. And so we're being able to do things like count cars in parking lots from 700 kilometers above Earth, and even estimate the strategic oil reserves, because there's things you just can't hide from the satellites, and even foot traffic with some near-ground stuff. Back to my research, I'll give you two little vignettes that I hope will show you the breadth of the stuff that we do. So we spend a lot of time worrying about plants. I'd say probably 75% of the time we're worried about plants, but increasingly we're worried about some other things too. So first I'm going to talk about climate adaptation for smallholders. Smallholders are simply farmers that cultivate small parcels of land. They're really important at the global scale. They produce about half of the calories or over half of the calories that are used by humans. They're also disproportionately impoverished people, and there's a lot of them in South Asia. If you look at these maps, the circles highlight our study region for this. It includes India, Nepal, and Bangladesh. We're focused in particular on the eastern portion of the Indo-Gangetic Plains at the foothills of the Himalaya. And you can see that the fields are really tiny, so that means most of the fields under 2 hectares, that's like 4 average suburban lot sizes put together. So most people are farming something that size or smaller across our region. And they're also, this is the highest concentration of impoverished people anywhere on Earth. So it's a really important region, and these people are very, very sensitive to the effects of climate change. In this region, you typically grow 2 crops on your field in the same year. You'll grow rice when it's raining during the monsoonal season. Then when the rains let up, you'll plant wheat, and you'll harvest the wheat through that spring and into the summer season. The wheat yields are really, really sensitive to hot temperatures at a particular time during the year, and we expect those temperatures to be increasing throughout the future. So one thing that farmers might be able to do that's accessible to even farmers that can't afford things like bigger fields and tractors and the latest genetics from Syngenta and stuff like that is simply plant earlier, and that will reduce the risk of being exposed to these excessive heat in the later season when it's really sensitive. So that's one thing that they might be able to do. But we just don't know what the adaptive potential is on the landscape. The farmers don't need us to tell them to plant earlier. But there's a lot of different factors that control when they do plant. And we need to know everywhere across this region when have farmers planted in the past, so we know, could they plant any earlier? Is this a viable adaptive climate solution? So the first thing we need to do was figure out a way to map when they're planting. So now this is characteristic of the work we do in my lab. It's not all AI machine learning. It's a blend of conventional statistics, domain knowledge, and then AI and ML sprinkled in. So the first part of this is not AI. We just said, hey, we need to figure out what time the farmers planted their crops. We do this by looking how green it looks from the satellites, and we put together a time series of those. That's pretty easy to do for most of the globe, but it's not easy to do when you have these tiny little postage stamp sized fields. High resolution data makes that possible, but there's way too much of it. You can't have the whole Earth at meter resolution every day, even though we could have that now. Your AWS bill would be too big. So I had a student figure out how we can augment moderate resolution time series by knowing when and where we need this high resolution stuff and use just enough of that high resolution stuff to get the same answers we would if we used all of it. And in doing that, we can eliminate about 80% of the data. So I know that we can scale everything up and just spin up 1,000 more instances. Maybe we should be smart in the future about how we do that. We had to do that here. We couldn't afford to do it in the dumb way or the unsophisticated way. And then another student of mine had a Bayesian statistical approach that allowed us to take advantage and solve some problems with sparse time series and borrow information from nearby fields and other time periods to come up with an estimate of the sow date. We do pretty well. You can see in that kind of scatter plot with low contrast, unfortunately, up in the upper right, that we do okay in predicting the date. Good. So we can do that for some places that we know when it happened. We know how well we did. Apologies for the figure, but this is North India. We picked a handful of districts, kind of state-scale things across India, Nepal, and Bangladesh. In the inset, you can see the fields. We measured at some 2,000 fields where the actual field boundaries were. So we got this big training data set. And now we need to make a map of all the fields. Well, there's billions and billions of these things across even this small geography, as you can see in that little zoom in. So my student Izzy trained up a UNet to do this sort of thing. Some of you are familiar with this. It's just a new CNN CV type of thing. It's been used in this application in the past. We've baked it off against other alternatives, and this is the kind of architecture that we ended up with. Now, for the Kaggle-minded folks that think domain knowledge has no place in the future of AI, I think it does, and this is an example that I'll show you. We do better if we look at different images, different time periods, but knowing what time periods to select the imagery from allowed us to have a much more efficient machine learning pipeline. So eventually we train these UNets with temporal differences, so we take images at the times we know things should be different SIM, and then we can compress that information and give a lower dimensional data set into the UNet, which helps everything. And out the other side, we get these nicely delineated fields. So we're doing pretty well on that front. Right now, we're working on scaling that up to tens of millions of fields at the regional scale to answer our question. Now, transitioning away from smallholder crops and crops altogether, we're involved in a project that is from the intelligence agency, another intelligence thing from like Bill. So these folks are interested in monitoring all of Earth all the time for big building, new building construction. And that sounds like a pretty hard thing to do. So we've joined together with a whole bunch of other folks across private institutions and other research labs to work on this problem. It's a really big pipeline. You can see that it's an eye chart in the upper left. We're just the kind of biggest box there that says BAS. Everything I'm talking about is broad area screening. And we're supposed to say, hey, I think something changed over here. It may be a building. And then you CV folks with your high resolution stuff tell us more about that building. So this is what we did. Again, blended approach. First thing we did, developed a Bayesian change point detection model, because why not Bayesian all the things? And you can see how that works. We just kind of fit a model. We think it works, and we look for when it stopped fitting. And we say, hey, I think something changed. Now, that works really well at finding things. It's a really, really good and sensitive change detector. When Laura first developed it, she was showing me these change maps. I say, there's nothing like that, because in remote sensing, we say 99.9% of Earth is not changing ever. And that's just the Bible for us. But Laura said, well, I'm not a remote sensing scientist, and everywhere I look, things are changing all the time. And I said, well, I guess you're right. So this is where the ML came in for us. We had to train up another model that took these sites that we think changed and say, hey, are these the types of changes we're interested in? Or is it just the field that greened up at a different time? Or is it this place that turned into a lake or something else? We only want big construction projects. So we trained up random forest, XGBoost, a whole bunch of different things, tree-based models that you guys are all familiar with. And you can see the difference. Here on the left, you can kind of see a GIF of the online mode. So up top, low contrast again, I'm sorry. We have unfiltered detections, and at the bottom, we filtered those down just to major detections. It filtered out a lot on the left. On the right, this is Dubai, or UAE rather, and so there's a lot of construction there. Not much of it was eliminated as being anything else. So the filter works pretty well. As I said, we're just one little box in a really big pipeline and a really big team, and so we have ML throughout this entire project. So upstream of us, we have CNNs running to identify the clouds that eventually slip through the upstream, like expert filters. Clouds get through, so we put a CNN on the job, and so that gets rid of those. We have spectral features being converted into materials maps. This is glass, this is concrete, this is a white painted roof, things like this. Even estimating the heights of buildings, which we can do with stereoscopic image pairs with just trigonometry, but now we're learning how to do with a single image and AI, which is kind of cool. And we even have a team that's saying, hey, what if we didn't even know what we were looking for? Could we make these maps as semantic features? And that's kind of the bleeding edge out there that we're working on integrating. So just to wrap up, I would say that remote sensing has had a lot of transformations over the time, technologically driven transformations, and it's mostly been about making it easier to get out off of Earth and get a higher perspective. So be it hot air balloons, eventually rockets. And now I think we're going to undergo a transition in remote sensing that's seeing what do we do with the data. We've been early adopters of machine learning, like random forests and stuff. Some of the earliest publications of that in remote sensing came within months of the first paper. So we've always been on it because we've always had problems that were naturally solved by that. But particularly computer vision coupled with this high resolution satellite constellations, that's going to change things dramatically for remote sensing in the next 5 years. And we're just trying to hold on so the wave doesn't break in front of us. And I say we, as you all know, I don't do any of this. My graduate students do. And so here's the whole team. It's the Spatial Ecosystem Analytics Lab, and we live up in the Center for Geospatial Analytics and in the CNR, College of Natural Resources. So thank you very much for your time.
Thank you, Dr. Gray. Whoops, losing it. And I just want to say thank you very much for all of our highlighted speakers. Big round of applause for everybody. Thank you. And thank you for working through our just a little change in our schedule. And that does bring us to our last item on the agenda today. And we're going to have a special screening of a documentary called Coded Bias. And just give me a couple minutes. We need to do a little bit of technology change up here, and we're going to transition the room for you for a in-room screening of this documentary. So if you give me about 2 minutes, we'll convert. And then I'm going to ask Dr. Genevieve Garland to come on stage and welcome a faculty member here at NC State who wants to give us a little intro overview of this documentary and what we'll be looking for while we're watching. So give us a couple minutes of technical change up, grab another piece of lunch, refill your drink, or get your dessert, and we'll be right back.
I know everyone may not be staying for the viewing. I just wanted to give you, thank you again for being here today, and then remind you that tomorrow we're going to have a panel on the AI Bill of Rights. We're going to have the Proposal Development Unit talking about opportunities for funding in the area. We're going to have lightning round talks. We're also going to have a facilitated session that Laura and I are going to lead, bringing people together around new ideas in AI and data science. So I hope that you're able to come back tomorrow and join us as well. So just wanted to thank you and appreciate your time here today. playing it from up here? Has he got it? Okay. Okay, I think we're ready.